Right, so here we have an API that allows you to retrieve information from using an API that supports CORS, right? Cross-origin resource sharing that you can do the queries right from your browser, right? Now, not all APIs support that. Right? If it doesn't support it, then the next thing you should look for is maybe it supports JSON-P. That's also equivalently easy to do, also from the client side, right? Although it's it makes use of kind of like a hack, right, to get around the security measures. But that is an accepted hack, right? If the server agrees and the client agrees, then it's fine. The next time, if it doesn't support either, right? Then the only thing you have is to resort to a server proxy, okay? Where the server is your server, your Node.js server is the one who's actually going out to the outside world to retrieve your queries, right? Instead of you generating your HTTP requests from the browser, you generate them from the Node.js server. And the Node.js server is not bound to the security measures that the browsers are. Right? The Node.js server can connect to anyone they want, right? As long as the recipient, the target server, allows them. Make sense? Right? So let me show you an example of that. Here we have an API, right? The Oxford Dictionary. It's a really nice API. It's documented here. I think I have it open. There it is. It's an API that allows you to query for word definitions, translation services. You give it a word or a phrase, right? You translate it from one language to another language. You give it a word in any language, and it gives you definitions, nouns, adverbs, all the different part of speech, different senses of the word. So, for instance, if you query this entries, sources, the language, you can tell it what language you want, what word you want, right? It comes back with a fairly large response, right, on the different meanings of that word. Okay, so this one doesn't support JSON-P, doesn't support CORS, right? The only way to hit this service is from the server side, right, not from the client. And the way it would work is that you have your Angular application, right? Whenever it needs data, it's going to generate a request, a get or post or delete, right? It's going to generate it to your server, like the services that we've been writing so far, right, for the last week or so. Yes? Right? We know how to do that, and there's no security. You're not breaking any security policies if you go back to your domain, right? Then what your server is going to do is going to listen for this incoming get from your Angular application, and it's going to turn around and grab your request and just send it over to the real target, right? In this case, the Oxford API. Okay, so the request is going to go from the Node.js as opposed to the Angular, right? So, well, Angular is going to do a get, right, using $get. It gets to Node.js. Node.js is going to use its own HTTP API, right, to turn around and send a get request to wherever you want to request from, right? The response is going to be buffered back to Node.js. You're going to have to buffer it, right, and build the response into one single string, right? And then you're going to convert it into a JSON object so you can pass it along back to your Angular client. That makes sense? Right, so I have sample code here that uses this API. But you should be able to refactor this for your own purposes. Okay? This is a very, very simple example. So here it is. So first of all, it's requiring the app, right? This is for declaring web service endpoints. These endpoints are the ones that your Angular client is going to call, right? So your Angular client is going to generate a get to your Node.js, yes? And here's where you're going to receive that incoming request, correct? Right? And so because you can't hit Oxford directly, you're going to come to your Node.js server first, then your Node.js server is going to turn around and is going to generate its own HTTP request to the target server. Okay? Now to do that, we're going to use the HTTP library. This is a Node.js HTTP library. It's not Angular's $HTTP library. Yes? Okay? Angular has nothing to do here, right? This is all Node.js. This is all running on the server. Now on the server side, you have two versions: the regular HTTP library or the HTTPS module, right? Some libraries will ask you to use secure HTTP as opposed to just plain old HTTP. Node.js supports both. Okay, so there's HTTPS. Here I have a library that I don't believe I'm using. Yeah, I'm not using it, so I'm just going to remove it. I don't need it. And now, your API might use keys, right, or tokens, or whatever, right, to be able to access it. I have stored it in environment variables, right? It's secure. So I store the application key, the application ID. I store it in local environment variables, which I'm reading back in. This is my handler. This is my search query right here. It's going to parse the language and word that I'm looking for from the parameters. There it is. I parse it. Once I have parsed it, I'm going to actually invoke the query. Right? I'm going to generate. There it is. Oxford search query. I'm going to pass language and word. There it is. There it is. I'm using https.get. Looks very, very similar to the $http.get. Yes? Right, but that one comes from the browser. This one is coming from the server. Right? So they both generate GET requests. Right? But the GET request coming from the Angular side is coming to this server. And then this server turns around and generates another GET. Okay? All right? So where is it going? To send the GET here, it takes an object that configures where do you want to send this GET request. Right? And we're going to send it over to Oxford's API, right? Its domain. That's the domain the domain for Oxford, the API, right? And here's the URL, the actual URL. Obviously, this is going to be concatenated to the domain. Right? So it's going to be domain / and then the path. Right? That's going to be the ultimate endpoint. Also, some APIs will ask you to put the keys and the IDs concatenated to the URL. Some other APIs are going to ask you to pass those keys as part of the headers. Right? So if we would be using OMDB, then it would be right here. Right? I would say key and then whatever key they gave me. Right? That's OMDB. But this particular API asks you to provide those as part of the headers. Right? It's going to parse them out of the headers. Each API will behave differently. Yes. So we're passing the app ID and the app key. I'm also passing a configuration that I wanted in a format, JSON format. Okay. Some APIs will allow you to configure different results, different MIME types. You can say maybe I want in XML format, maybe I want in text format, maybe I want in tab delimited. Some of them allow you to do different things. This one allows you to ask it in XML or in JSON. Here I'm saying that I want JSON. All right, are we okay? So this is going to go out to the Oxford server, and then the server is going to send back a response. Right, there's a response. Notice that the second argument to the GET, is a function. It's a callback, right, giving you the response. Right, but this is not the same response that we get when we are on the client. Okay, this response is a little more involved. Right, so this response it allows you to, if the data is buffered, right, it might be that the data from the server doesn't come in all in one chunk. right? Depending on the size of the data, right? The data might come in different, in bits and pieces. Yes, right? And this allows you to recreate or reconstitute, right, all those bits and pieces into one large response. Okay. So what it allows you to do is to listen on each buffer piece that gets sent over, right? And as you receive those pieces, we're just going to concatenate it into a local variable. See that? We're just going to concatenate it and build up the entire response into its original body, right? Once we have that, right? When the buffer ends, when the server has done flushing all the stream that comes from that server, it's going to send an end event. It says, that's it, there's no more data, right? That's a flag for us saying, we're done, there's nothing else to do, right? We can now go back and send this to the client, right, who's been patiently waiting for us. Yes? Okay. So what do? We're going to take the string that we've been accumulating over several buffer events. We're going to parse it into JSON because we asked it as a JSON. What we get back is a string. It's just a string that needs to get parsed into JSON. Now it's JSON. Now the body is JSON. It used to be a string. Now it's a JSON. And then we're going to resolve. So this resolve here, this is us using the Q library to handle, to have more control over the promise lifecycle. Right? Notice that the first thing that we do when we came in here is that we created a promise, right? Using the Q library. Remember, we used the Q library, I think on Monday, right? We told OMDB Mongoose. We told Mongoose, hey, don't use your deprecated promise library. Use the Q library. Remember we did that on Monday? Well, that is telling Mongoose use this library. Here, we are using it ourselves. This is what internally Mongoose does, right? It creates a deferred object, right? It does its communication to the database, right? So it creates a deferred object, and it immediately sends us back a promise. This promise is the one that has the then function, right? That is the object that has the then function that allows us to register ourselves, okay? And whatever function we give it, will be invoked by this. When we say resolve, when we say deferred resolve, that function we had registered with the then, that's when it's going to be called. Okay, when we resolve the promise. You see that? And that function, right? Remember the then takes two arguments, right? Two functions. The first function is called if we resolve the promise. The second function, the failure function, is called when we reject the promise. You see that? So this is low-level promise mechanism, okay? Mongoose hides that from us at all, completely. Right? We don't have to deal with that anything. We just do a dot then, that's it. We just do a return, and the other side we do a dot then, right? Mongoose does all this, send the promise back, resolve, reject, blah, 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 all that, right? It hides it from us. But here we're doing it ourselves because we don't have Mongoose. Right? We're doing the raw network communication to the server. So we have to handle all those promises and resolve it ourselves. So there it is. So that when we create the deferred and we return the promise, notice what the Oxford query says. This is where we're using the then. See that? We are registering the two functions. This function will be called if we resolve, and this function will be called if we reject. See that? Right? And what we're doing is that we're doing a try. Try to parse this into JSON. Right? If you fail, if this can't be parsed into JSON because somehow we got XML instead, we're going to do a catch, and we're going to reject the promise, and the second function will be invoked. Yes? If we successfully parse this JSON, we're going to resolve, and we're going to pass this. This is the data, the body that we pass into the resolve function. That's what gets passed into the response of the first function. You see that? Right? And that's exactly what we sent back to the client. Does that make sense? Right? Right. So I think this is generic enough that you should be able to grab this and and use it. I put it under experiments, Oxford, and services, and I will push this code later tonight. If you need it, if you need a proxy, you can use this proxy. Everybody good? All right.